Good morning, everyone. Myself, Dr. Kritika, Assistant Professor, working in SRM Institute of Science and Technology. Today, we are going to see about the high performance skin, how the evolution of tall building facades have happened. So, before we begin, I want you to look out to the nearest window at any tall building you can see. What you are looking at, what covers the vast majority of its surface, is a facade, a skin, and for most of architecture's history, the skin was treated as single little more than a wrapper, a weather shield, a visual signature. But today, that skin has evolved into something far more sophisticated. It is no longer passive, it is no longer dumb. The modern high performance facade is active, intelligent, multifunctional, generating energy, resisting wind, filtering air, and even supporting biodiversity. Today, we are going to trace the evolution of these facades from basic enclosure to high performance skin. We will explore the engineering breakthroughs, the real world case studies, and the future that are already being built. So, to understand these facades, we first need to understand the buildings they wrap. Not all tall buildings are created equal. As the height decreases, the facade's job becomes exponentially more complex. Let's look into it. Tall buildings, which are 50 meters and above, this is the baseline threshold for vertical urban density. At this scale, facade decisions matter. They are still manageable, but with conventional engineering. While the skyscrapers that are 100 meters and above, this is where things accelerate. Structural behavior changes. Wind loads intensify. Thermal bridging becomes a serious problem. The facade is no longer just a wall, it is critical structural environmental interface. And while speaking about the super tall structures, which is 300 meters and above, at this height, we are pushing the absolute limits of wind engineering, thermal science, and also the material performance. The facade isn't just a part of building here. In many ways, it is a building's primary defense system. Here is a key insight. The facade is more for than a visual signature. It is a primary barrier which regulates interior comfort, energy consumption, and structural wind resistance. If you are getting the facade wrong, and with the best structural system in the world, can't save you. Get it right, and you have solved half the building's performance problems before anyone moves in. And what is the core challenge? Which is nothing but efficiency versus aesthetics. It is not a technical problem but a philosophical one. Efficiency versus aesthetics, performance based versus beauty. Why is this tension so acute? There are two reasons. High rise buildings demand specifically more energy than low rise structures. Think about it. Vertical transpiration system is there, pumping water more than 60 stories, and more critically, requirements because they are fighting gravity and exposure on every floor. The taller you build, the harder the building has to work just to stay comfortable. Secondly, the designers face fundamental conflict of occupants. Here, the occupants want daylight, they want views, they want transparency. But to achieve this, you need to provide more glass. But every square meter of glass is a square meter of thermal liability. In summer, solar heat gain, and in winter, there is a thermal loss. This very feature makes a skyscraper desirable. Its transparency is also what makes it energy hungry. There is a puzzle at the heart of high performance facade design. How do you give the people the light and also the views at the same time without changing the building into a energy furnace? And the solution we are about to explore is the answer to this exact question. While speaking about this, there are two typologies, opaque and glazed. What is the opaque system? It is nothing but a solid material which is made of stone, concrete, and metal panels. These offer high insulation values, thermal mass, and also ideal for minimizing heat transfer in extreme climates. But while thinking about the views and also the daylight, it is a hard sell. But while speaking about the glaze system, it is made up of curtain works. It can be either single, double, or triple, providing transparency and also views. Here is what the engineer need to work on: low emissivity flames, argon-filled cavities, advanced coatings, which aren't luxurious anymore but are essential to mitigate, so that to help the building from bleeding energy. Here is the reality. Most high performance facades today are hybrid systems. They combine both worlds, where strategic opacity, where insulation matters, and to strategic transparency, where daylight and views matter. The art is knowing where to place each of them. And here comes the elegant solution in the facade engineering, which is double skin facade. The two glazing layers that are separated by a ventilated cavity. The cavity isn't just an empty space but a dynamic thermal buffer zone. How it is behaving depends on the season. Winter mode is nothing but the cavity traps solar heat. As sunlight passes through the outer glazing layer, it warms the air in the cavity. That pre-warmed air is then drawn into the building, reducing heating demand. The facade becomes a solar collector. While during the summer, this cavity becomes a protective layer where the overheating is happened and it behaves like a chimney. Year around, this single system dramatically reduces energy loads, not by adding complexity but by using natural forces that are already there. Sun in winter, take effect in summer. The double skin facade doesn't fight climate, it dances with it. And the future of automation. Double skin facades are brilliant, but they are still passive. They respond to physics, not to real-time conditions. The next evolution is intelligent facades, facades that uses AI. Let me show you what's possible with one extraordinary example: the Abu Dhabi Investment Council Tower, where 2000 automated shades are there. Not one big blind that covers the whole building, but 2000 individual umbrella units, each operating independently. Think of them as tiny facade robots. 50% cooling load reduction, that's the estimated savings from dynamic solar shading while still maintaining highlight transmission. The building stays cool without going dark. There is a 24/7 real-time response. These shades don't operate on the timer, they just continuously tracking the sun's path, reading weather conditions, responding to cloud cover every minute, every hour, and every day. This is the future of automation. The facade is no longer a static object but a responsive manner membrane, an interface between the interior and exterior which adapts in real time. The building doesn't just occupy its environment, but it reads it, it reacts to it. Let's move on from intelligence to energy generation. Let me tell you about GreenPix in Beijing, a building that redefines what facade can be. GreenPix is a self-powered media wall. It integrates around 2200 LEDs with photovoltaic laminated glass. The facade is simultaneously an energy generator and a digital canvas. During the day, the photovoltaic glass harvests solar energy across the entire building surface. Every panel is a tiny power plant. At night, the stored energy powers the facade's dynamic LED display. The building communicates. It becomes art. It becomes media. Think about what this represents. The fire facade It's no longer a cost center, it's a revenue stream. It's no longer just enclosure, but it's an expression. It proves that sustainability and spectacle aren't opposites. When you design for performance, you can also design for wonder. Excuse me. There are two converging trends that are reshaping facades from opposite directions. Living walls. These are modular, hyperphonic, vertical ecosystem integrated directly into facades. These aren't decorative planters, they are active environmental systems. They mitigate the urban heat island effect by cooling the building surface through evapotranspiration. They improve air quality by filtering particulates, and they restore urban biodiversity by creating habitat in the sky. A living wall isn't just greenwashing, it's infrastructure that happens to be beautiful. And secondly, parametric design. This is where data meets geometry. Tools like Grasshopper allow designers to optimize every panel based on site-specific conditions, sun exposure, wind loads, structural requirements. No two panels need to be identical. We can mass customize facades with the same efficiency we once reserved for mass production. And here it is connecting the two. Living walls brings nature into the facade while parametric designs brings intelligence into the geometry. Together they represent the future where every square meter of building skin is optimized for a specific place, its specific climate and its specific function. And the facades as load resistor. This is the structural power. We have talked about facades managing energy, generating power, and supporting ecosystem. Now let's talk about the most radical evolution of all, facades as structural system. Advanced facades no longer just enclose, they actively resist seismic loads, wind loads, and lateral pressure. When the envelope becomes a structure, two extraordinary things happen. First, you free interior space. If facades carries lateral loads, your columns and core don't have to. More usable floor area will be there, and more flexibility and more value can be made. Secondly, you improve performance. A facade designed to resist wind is by definition the facade designed to manage wind. The structural solution and the environmental solution becomes the same solution. Two examples. Taipei 101. It is a double pane glass curtain walls or engineered to withstand 95 mm of seismic displacement without failure. In an earthquake zone, it is not a feature but it's a survival. And next one is exoskeleton system. These are the structure like Bank of China Tower move lateral resistance outside the building line. The structure becomes visible, expressive, and functional all at once. Performance and aesthetics finally combine together. And the sustainability future where the energy neutrality is beyond. We have covered almost all from basic typologies to intelligent automation, from energy generation to structural integration. So, where does it all lead to? That is, it's clearly the ultimate goal is a paradigm. From energy consuming enclosures to carbon positive, responsive systems that give back more what they take. This isn't incremental improvement, but it is a complete redefinition of a building facade and does. There are three principles. First one, site-specific design. Climate orientation and context must drive every facade decision. A facade that works in Dubai will fail in other area. One size fits all is dead. Data-driven strategy. The real-time monitoring and adapting system for peak performance. The facade for the future is a sensor network, a computing surface, and an environmental regulator all in one. Architects and engineers must unite together to meet the climate challenge which has been heading on. The facade is too complex, too critical for any single discipline to own alone. The high performance facade is not the end of its revolution, but it's a beginning. The buildings we construct as the next few decades will determine whether our cities can sustain 7 billion people or whether they become part of the problem. We have the technology, we have the knowledge. The question is whether we will have the will. The facade was once an afterthought, the last thing designed, the first thing compromised. Today is the frontier of architectural innovation. High performance facade prove that we don't have to choose between beauty and efficiency, between transparency and thermal comfort, between structural integrity and environmental responsibility. We can have it all if we are willing to design for it.